Good morning. Today's lesson is on section 6.1, the polygon angle sum theorems. We're going to solve problems using the sum of the interior angles and the exterior angles of a polygon. So let's move on to the notes. You should have received a notes worksheet. Actually, two notes worksheets. So let's fill them out. So let's read the interior angle sum. The sum of the degrees in any polygon can be determined by the number of triangles that can be drawn within the polygon. Complete the table below and look for a pattern to find the sum of the degrees in any polygon. So we have, in this picture we see a triangle. The triangle has three sides and we have one triangle. The sum of those angles is 180 degrees. We're experts at this by now. In a quadrilateral, a quadrilateral has four sides. How many triangles can we draw inside a quadrilateral? Two. From one vertex to opposite vertices, we can only draw two. So two triangles, with each triangle having 180 degrees, gives us a total of 360. 2 times 180. Pentagon, we can draw three triangles, all coming out of one vertex to opposite vertices. So we get 5 sides in a pentagon. 3 triangles can be drawn. Each triangle has 180 degrees for a total of 540. 180, 180, 180 equals 540. Hexagon. 6 sides. 1, 2, 3, 4. 4 triangles. Each triangle has 180 degrees. 4 times 180 is 720. So do you notice a pattern? We have compare the number of sides to the number of triangles that can be drawn. So if we go from 6 to 4, or 5 to 3, or 4 to 2, it's minus 2. So I'm going to write that in here. And the number of triangles times 180 gives us the sum of the interior angles of any polygon. So let's try it now. We don't need a picture anymore. Let's follow the pattern. Heptagon is 7 sides. That means we'll have 5 triangles inside of it for a total of 900 degrees. Octagon, 8 sides. 6 triangles can be drawn. 6 times 180 is 1080. Nonagon, 9 sides. 9 minus 2 is 7, so 7 triangles. 7 triangles times 180 is 1260. Decagon, 10 sides, means we can draw 8 triangles inside of it. 8 times 180, 1440 degrees. So in summary, we can come up with a method to solve the sum of the measures of the interior angles of a convex anigon is 180 times n minus 2. So let's write that down in our notes here. The sum of the angles is the number of sides minus 2, so the number of triangles times 180. And there's a corollary to that theorem. So if you want to find, let's say, the measure of just one of those angles of a regular polygon, you'll take the sum and divide it by the number of angles you have. So a 5-sided figure also has 5 angles. And if we want to review the definition of regular polygon, it means all sides and angles are the same, or they're all equal. So we take our sum for our pentagon here. In this example, a pentagon here, this whole thing is 540 degrees, and we'll split that up evenly with all those 5 angles, which is 108 degrees. So in our notes, a regular polygon is one in which all sides are equal. Therefore, all angles are equal. To find the measure of an interior angle in a regular polygon, has to be regular, we say we use the sum of the interior angles, like we just figured it out, number of triangles times 180. Take that sum and divide it by the number of angles. So, the sum of the interior angles of a 15 gun. Pay attention to those details. The sum of the interior angles of a 15 gun. So we'll use n minus 2, find how many triangles, times 180. So it's 13 times 180. $2,340. Number 2, we're going to take the 21 gun. The number of triangles would be 19 times 180, which is 3,420. And in this next problem, it's asking for the measure of each interior angle. Each is that keyword there. So just one interior angle of a pentagon. So let's find the sum of all the angles. 5 minus 2, we have 3 triangles, times 180 equals 540. And we're going to divide that by 5 because we have 5 angles, 5 equal angles, which gives us 108. 108 degrees for each angle. Now, what is the measure of each interior angle of a regular 18 gun? Each interior angle, so just one. So find the sum first. Gotta find the sum, 18 minus 2, 16 triangles times 180, and then we'll divide that sum by the 18 angles. So 16 times 180 is 2,880 divided by 18 is 160 degrees for each angle. So that is the interior angles. And next we'll look at the exterior angles. So when you look at exterior angles, let's move on to the notes because I want you to see something yourself. So let's look at, the exterior angles are always supplementary to their adjacent angle. So 79 and 101 is its exterior angle. 40 degrees, 140 is the exterior angle for that vertex, and in the 61 degree angle, its exterior angle there is 119. So go ahead and add 119 plus 101 plus 140. And what do you get? 360 degrees. So we're going to get all the exterior angle measures. And then we add them all up. And amazingly, this one is also 360. Once again, we will add all of our exterior angles. And when we find the sum is 360. Once again, last one in the hexagon. Here's 65, 51, 56, 68, 57, and 63. Add all of those, and the sum is 360. So the conclusion we can make is that the sum of the exterior angles of any polygon is 360 degrees. Very easy to find that sum. So exterior angles practice is next, number 5. What is the measure of each exterior angle of a regular hexagon? So let's think about it. If we have the sum of the exterior angles is 360, and if we have a hexagon, it's going to have 6 exterior angles. Divide. Each angle will be 60 degrees. Similarly, if you have a 24 gun, you take 360 and divide by 24. What do you get? 15 degrees. So if the exterior angle of any regular polygon measures 12, how many sides does the polygon have? So you're thinking to yourself, well, 12 times how many of those angles is 360? So to find that missing number, you have to take 360 divided by 12, which will be 30. So 30 sides. So whether you're finding an angle measure of one exterior angle or the number of sides, you're going to divide. If you think about it, 30 times 12 is 360, so you can use those interchangeably in your division. Like you can switch depending on which one you need to find. So we have here the measure of a regular polygon. One exterior angle is 40 degrees. So we have 360 degrees. Let's split that evenly with 40-degree angles. How many angles would we have? Or how many angles would we have? How many sides? Same as how many sides? We'd have 9 angles, meaning we have 9 sides. So that's going to be our first video. This concludes the first worksheet, notes worksheet. Please move on to the second video for the second notes worksheet. Thank you.